Everyone, in this video we're going to talk about selective precipitation, talk a little bit about what it is, how it works, and how to solve questions with it. So a typical selective precipitation problem will look like this. Example, imagine we mixed AgNO3, CuNO3 and MgNO3 all together in a beaker. That is what the question will look like, and what we are going to want to do is selectively precipitate, so make solids out of each of these metals. Now what you'll notice is that there is a common feature of each of these. That common feature is the NO3. And if we look at our data table and reference booklet here, we can see that anytime we have a nitrate, anytime we have this NO3, we are dealing with something that is soluble. We're dealing with something that wants to dissolve in an aqueous or in a water situation. And so what that means is that each one of these parts will be aqueous when we pour them in the water, and so we could do a dissociation equation for them. What we're then going to be given is a bunch of cations to bring stuff out of that solution. We're given Na2S, NaCl, and NaOH. And what you'll notice with those ones is that when we go to this data table and we look for our alkali ions, anytime you see alkali ions, they're soluble. Alkali ions, soluble. Alkali ions, soluble. And so basically anytime we have a sodium, we know that that is going to be soluble. And so what we then have is the potential situation for the formation of a NaNO3, which is very soluble. And so when people are trying to pull certain things out of a solution, they will give us two very soluble things. And so now what we can start to think about with this question is, because we know all of those NO3s are soluble, what we're actually dealing with is a silver ion, a Cu2+ ion, and that 2+ is there because we know that NO3 had this little 2 beside it, so we're dealing with the Cu2+, and we're dealing with the magnesium 2+. If you're ever unsure of what ions you're dealing with, you can scroll up on your data table and take a look at the table of ions, and that'll give you the information with the charges that you need. Now, when we look at these other compounds, what we can see is that we're actually dealing with a sulfur, a chlorine, and a hydroxide. We're dealing with an S2-, a Cl-, and an OH-. And so what we can think of then is that these NAs and these NO3s are just our spectator ions. They are present in the solution, but they are not important in terms of creating precipitates at all. And so what we want to do now is combine a couple of these different ones and form precipitates out. But the problem that we'll run into is, let's say for example we add Ag in, it might precipitate out the sulfur and the chlorine, and that doesn't really work. Or because we want to get these metals out, let's say that we add the sulfur in and it precipitates all three of these things out. Well, that doesn't work. We want to precipitate one thing out at a time. So basically the tools that we're given are these guys here. These are the tools that we are given to try and isolate, we want to ISO these guys up top. And so what we're going to do is we're going to set up a chart and basically allow us to predict what precipitates will be present. So the ions that we have that we want to pull out were the Ag2+, the Cu2+, and the Mg2+. Those are all of the ions that we want to pull out. And one of the things that I always tell my students is be careful how you draw the table. Because what it might influence is it might influence how you actually go about reading the information. So these are the three things that we have. And then what we're going to add in is that S2-, the Cl-, and the OH-. And so because we have the things that we want to add, because we have our tools over on this left-hand side, we're going to read this table left to right. Because what we want to think about is, if we add sulfur in, well, what will happen to the Ag, the Cu, and the Mg2+? And so we're going to fill this table out. We're going to look specifically just at the sulfur for right now. So going down to our solubility chart, we look at this sulfide, and we want to see if we can find the following information: the Ag, the Cu2+, and the magnesium. AgCu2 plus the magnesium. So what we can see is that the magnesium here, this magnesium will be soluble, and it looks like the other two will have low solubility, so we say that those would form a precipitate. So we have PPT for precipitate, PPT, and I will write soluble for the magnesium. So right now, looking at this, if we were to add that sodium sulfide solution in there, we'd get two precipitates, the Ag and the Cu2+, which means now we have two powders, two solid powders that we need to try and separate. That would be like you trying to separate the salt and pepper that you put on top of your eggs. It's very difficult, and nobody wants to do that. So now let's look at Cl, and we're going to again look for the AgCu and the Mg. So we're looking at the Cl, the chloride. We can see Ag here has a low solubility. This is Cu1+, that's different than Cu2+, and then we can see that anything else here will be soluble. So we know that the Ag will form the PPT, this will be soluble, and this will be soluble. Again, Cu2+ is different than Cu1+. So it will not form a precipitate. The last one to look at here is the hydroxide. And what we can see is that anything alkali ions is soluble, anything else will have low solubility, so we are dealing with all three of these being possible precipitates. So the one you absolutely don't want to add in first is the hydroxide, because you will get three precipitates. That would be like having salt, pepper, and now paprika that you need to try and separate from each other. It's not going to happen. It's going to be pretty tough. So what we're looking for is, I said we want to read this chart left to right. We want to read it this direction. And what we want to do is we want to choose one of them that forms only one precipitate. So only, keep hitting my print button, only one precipitate. And so what we can see right now is that this chlorine will actually precipitate out this silver, but it will leave the copper and the magnesium in the solution. So the first thing that we want to add is the NaCl. Remember that Na was just the spectator ion, and so it doesn't play a role in this at all. Now the nice thing is, once you add this in, you can cross out this entire column. We don't need this information anymore because we've precipitated out the Ag. And let's try using a black color here and see if that will help resolve this issue. So we don't need to worry about these two columns anymore. And we don't need to worry about the chlorine anymore. And so we can actually cross these two sections out as well. And so now what we're looking at is, again, we want to choose one of the, either the sulfide or the hydroxide that only forms one precipitate. And what you can see is that we are going to choose this right here. It will only precipitate out that copper. So we're going to second use the Na2S, and that will precipitate out our copper 2. And so what we have left then is the hydroxide, and because this has been removed, we will only precipitate out that last one, that magnesium, so we'll add in third the NaOH. Now some questions, what they'll ask is the actual compounds that you'll end up forming. So because we added the Cl, the S, and the OH in specifically to precipitate out those compounds, what we would know, I'm just going to do this and clean up our chart a little bit here. What we would know is that we are using this OH to precipitate out this, and we're using this sulfur here to precipitate out this. What we would know is that we're going to combine that copper and the sulfide. We're going to combine the Ag and the Cl. So Ag plus Cl minus, that goes to form AgCl when we swap and drop. With the Na2S, sulfur has a 2 negative, copper has a 2 plus, we're forming a CuS. And then the last precipitate that we're forming is this magnesium and hydroxide, so Mg bracket OH2. And so those are the three precipitates that we're forming out, but this allows us to precipitate out these metals in order selectively. And so that's where the term selective precipitation comes from. And so this is an example of how to precipitate out three different metals using three nonmetals, and that is how you do selective precipitation.